Okay, students, I hope you do well with that final material. Now we'll talk about the final exam review. This is page 1, question 1. In question number 1, we have an astronaut with mass 58 kilograms and the time for one revolution is 5 minutes. Okay, first we need to find the angular velocity. The angular velocity is 2 pi f. F is the frequency. Also it is equal to 2 pi over the time period. The time period is 5 minutes. I need to put it in seconds. Each 1 minute is 60 seconds, then the time period is 300 seconds. So the angular velocity is 2 pi over the period, which is 300, then it will be 0.02 radians per second. So the angular velocity is this value. Okay, if the radius is 8 meters, this is the radius, what is the tangential velocity? V tangential. V tangential is equal to omega multiplied by r, by the radius. Omega is found now, r is given, then the linear velocity or the tangential velocity will be 0.16 meters per second. Okay, now the centrifugal acceleration AC is equal to v squared over r. From before we know this relation, and also we know that it is equal to r omega squared, because v is equal to r omega. We can use this relation or this relation. I find the acceleration using this one and this one. By using the first one, it is 0.16, which is this one, the tangential velocity squared over the radius, which is equal also the radius multiplied by omega, which is 0.02 squared, which gives the same value, which is 0.0032 meters per squared second. This acceleration is toward the center, AC. Okay, now D. If this astronaut has acceleration in negative value, it is alpha, it is 0.01 radians per square second, but in negative value it is the acceleration, because we have omega 2 is 0, because at the end it is stationary. So what is the tangential acceleration? Tangential acceleration, it is in the tangential direction, because we have this is v tangential, and the acceleration, it is with negative value. It means that the direction of it in the opposite of the velocity, tangential speed. So the radius is 8 meters. The angular acceleration is negative 0.01 radians per square second, which is equal to negative 0.08 negative acceleration, or we can put it in 0.08 as you see in the review solutions, and it is deceleration. Okay, we know that the body is stopped at the end. Okay, we have now found the acceleration, the centrifugal acceleration, this value, and we need to find the total acceleration. If we don't have any tangential acceleration, then the total acceleration is equal in general AC squared plus AT, A tangential squared under the root, because this is the tangential acceleration and this is AC, and the total acceleration is between them in an angle phi, as we will see. If the tangential acceleration is 0, if it is 0, then the total acceleration will be just the centripetal acceleration. But with acceleration A tangential, as we find it here, 0.08 meters per second, square second, then we can use it in this relation to find the A total. A total will be equal to 0.08 meter per squared second. We can find the angle phi. If this is the tangential acceleration and this is the centripetal acceleration, then this is phi. This is AC again, and tan theta is equal to AC over AT. So tan inverse for this theta, or tan inverse to AC over AT, is equal to phi. Phi is equal to 2.3 degrees. Be careful when you use the calculator when you are using radian system or degrees system. Okay, this is A total. We use the AC and AT squared with the Pythagorean theorem. Okay, now if we need to use that now, the angular velocity equations, we know them for linear motion is V2 is equal to V1 plus AT. If you remember, V2 squared is equal to V1 squared plus 2AX in X direction, for example, and we have X is equal to X naught plus V initial multiplied by T plus half AT squared. We have now angular motion. We will use this form but in angular version, okay? We have alpha is negative 0.01. Yes, we have it. Yes, right. And omega 1 is 0.02 radians per second, and omega 2, as given in the previous part, is 0. So we can find them, put them in the formula. This is 0, this is omega 1, alpha is given also, alpha with negative sign as we see before. Then we can find t is equal to 2 seconds. Now, if we have for this astronaut motion, if theta initial is equal to 3 pi over 2 radians, what is theta final when we reach omega final is equal to 0 after 2 seconds? We will use this equation but in angular motion version, which is theta final is equal to theta initial plus omega initial, which is the velocity multiplied by the time, plus half the acceleration multiplied by square root of the time. Just put the values, numerical values. Don't forget that the acceleration is negative. Then that theta final is equal to 4.73 radians. It is the same as you find the x final. Okay, this is all for this first question. Thank you. Solve it by yourself.